exploring confounding variables versus causal links. So let's go ahead and get started. So now these may be a bit confusing, so we're going to be doing an activity today to help with that. But first things first, let's go ahead and start with definitions. So confounding variables are variables that affect both the treatment and the response. And here's two factors to determine if a variable is a confounder. One, it is correlated to the treatment, and I have a diagram to the right here, as you can see. In the center is a confounding variable, so the confounder must be correlated to the treatment. This is also known as the independent variable, and it also causes the response. So that's why I have an arrow pointing from the confounder to the response, because it causes it. The response is also known as the dependent variable. So this is a fairly straightforward definition, but we'll go ahead and go more into depth later. And a causal link is a variable that if a treatment truly causes a response. So it's a variable that makes the treatment truly cause the response. That's how you know it's a causal link. Usually causal links are related to the response in some way. So in studies or medicine, most of the times it's an ingredient in the medicine or in the actual response that makes the treatment cause the response. So it's related to the response. It's it may be a part of the response or an ingredient within the response that makes this causal link happen. So here is my treatment. I have an arrow going from the treatment to the causal link, and then an arrow from the causal link to the response, because all of these are connected. And the treatment, this is a variable that makes the treatment cause the response. All right, so let's go ahead and look at an example. That's the best way to learn things. So let's look at an observational study. Confounding variables only happen in observational studies because that's where we're really observing all of the data that occurs. So that's where these confounders can take place. So observational study is the effect of a lack of exercise on weight gain. So with my diagram, I used this similar diagram to help me determine whether my variable is a confounder or a causal link. So in the left side, you want to write your independent variable. So our independent variable is a lack of exercise, right? Because we want to see if a lack of exercise has an effect on weight gain. And I'm going to leave space for my arrows. And then on the right side goes my dependent variable, and that is weight gain. So I'm going to write my dependent variable on the right-hand side. All right, so in this activity, we're going to go ahead and look at three variables. And we're going to see if those are confounding variables, if it's a causal link, or if it's neither, which can actually happen. So let's go ahead and take a look at excess calories. All right, so if you want, you can go ahead and pause the video, try to figure out which one of these categories this variable belongs to, and then unpause whenever you're ready. All right, so let's go ahead and try to tackle this out. So excess calories is a variable that is, so a lack of exercise causes an excess of calories in your body. So I'm going to put an arrow here because a lack of exercise causes an excess calories in your body, and an excess of calories in your body causes weight gain. Because if your body stores too much fat, then too many calories, then those turn into fat, which causes weight gain. So in this diagram, it's similar to the one for causal link because this treatment causes this variable to take place, an excess in calories, and an excess calories causes weight gain to occur. So that's how we know excess calories is a causal link. So I'm going to go ahead and reset my diagram so that we can look at another variable. And whenever you have observational studies and you want to find which variables are confounders or causal links, I would highly recommend drawing this diagram out and seeing the arrows and seeing if those are related to the treatment and response in which ways, so that they can help you decide the relationship that variable has with the treatment and response. So our next variable is actually genes. So go ahead, you can always pause the video and unpause whenever you're ready. All right, so genes are actually not related to a lack of exercise. It's not like my genes or my family history will affect how much exercise I do. That's not a thing. So I'm going to put a question mark here because genes aren't actually related to this independent variable. However, genes can have an effect on weight gain. For example, if your family has a high history of obesity, then you may have a higher chance of being overweight. So I'm going to put an arrow from genes to weight gain because certain genes can cause you to gain weight. So that's why I put an arrow here. And from this diagram, we can see that genes are actually not a confounding variable nor a causal link, because genes aren't even related to the independent variable. There is a connection between genes and weight gain, but there's no connection between lack of exercise and genes. So we have to say that genes is actually neither one of those, which can actually take place. So that's something interesting. And I'm going to reset our diagram, then we can go on to the last variable, which is going to be age. So again, pause and unpause whenever you're ready. All right, so your age can affect how much you exercise. For example, older people may do less exercise because they may find it harder to move around. So that's how age is correlated with a lack of exercise, because older people may not exercise as much, as it may put too much stress on their bodies. So I'm going to put an arrow that points from age to a lack of exercise. Notice my arrow is not pointing this way. That's incorrect, because a lack of exercise doesn't cause or affect your age in any way. It's the other way around. Your age may have an effect on how much exercise you do. So we want to be careful of the direction of the arrows. And now for this side, your age can have an effect on weight gain, because older people are more prone to gaining weight and being obese than younger people. So that's how you know that age has an effect on your weight and how much weight you gain. So that's why I put an arrow from age to weight gain. All right, so from this diagram here, we can see that age is a confounder because it affects both the treatment of a lack of exercise as well as the response of weight gain, because it is correlated to the treatment and causes a response. So that's how we know that age is a confounding variable. So as we can see from this activity, hopefully it was helpful in giving you some tips and a plan of action and a diagram to use when deciding which variables are confounders or causal links. As we can see here, it's pretty important to identify confounding variables within your study, because if left unchecked, confounders can skew your data results and lead to misleading results, which can lead to bias, research bias, which nobody wants, right? So we control for confounding variables and take into account which variables we want to control for, to make sure that there is no third confounder that affects both our treatment and our response. So we want to be pretty careful that all our variables in our study are directly related, are variables that make the treatment truly cause a response. So they are all causal links here. And confounders can really skew our results if we're not careful with that. So I hope this activity helped everyone, and I'll see you in the next video. Bye.